Hey everyone! Today we're diving into the essential parts of a 3D printer. Whether you're a beginner who just unboxed your first magic plastic pooping machine, or a seasoned pro who's seen more filament jams than I've had questionable project ideas, knowing these parts is crucial for your 3D printing journey. Seriously, understanding what makes these things tick, or sometimes frustratingly tick, is the first step to becoming a true 3D printing whisperer. Or at least, someone who can fix it without wanting to throw it out the window. We've all been there, right? Think of this as your friendly, slightly chaotic backstage tour of the 3D printer. We're not just going to name parts. We're going to get to know them, understand their quirks, and appreciate how they all work together to turn a spool of plastic into, well, anything you can imagine. Or at least, anything that fits on the print bed. Knowing these components will empower you to troubleshoot problems like a boss, make informed decisions about upgrades, because who doesn't love upgrades? And generally just marvel at the incredible technology you have at your fingertips. It's less about being an engineer and more about being a curious explorer. So grab a metaphorical wrench, maybe some safety goggles, because why not? And let's get acquainted with the stars of the show. By the end of this, you'll be looking at your printer not just as a tool, but as a collection of fascinating mechanisms, each playing its vital role. And hopefully you'll be a little less intimidated and a lot more excited to print, tinker, and maybe even invent something wonderfully unnecessary. Let's do this. Alright, first up is the print bed. This is literally where the magic begins, the stage upon which your 3D creations are born, layer by painstaking layer. Think of it as the foundation of a house. If it's not right, everything built on top is going to be a bit wobbly, to put it mildly. Its main job is to provide a flat, stable surface for your print to stick to during the printing process. And I mean stick. There's nothing quite like the heartbreak of a print coming loose halfway through and turning into a modern art piece I like to call Spaghetti Monster's regret. So, a good print bed and good adhesion are absolutely non-negotiable for successful prints. Now, print beds aren't all created equal. Some are heated, some are not. A heated bed is a game changer, especially for materials like ABS or PTG that love to warp and curl up at the edges like a shy hedgehog if they cool down too quickly. I remember my first printer didn't have a heated bed, and oh boy, the warping was real. It was a constant battle. Heated beds help keep the base of your print warm and happy, encouraging it to stay put. Then there are the surfaces themselves: glass, build tack, PI sheets, magnetic flexible plates, each with its own cult following and list of pros and cons for adhesion and removal. It's like choosing the right tires for your car, but for plastic. And let's not forget the most crucial ritual involving the print bed leveling. If your bed isn't perfectly level and at the correct distance from the nozzle, you're basically trying to build a skyscraper on a trampoline. Not ideal. That first layer is everything. Too close and the filament gets squished and nothing comes out, or you might even gouge your bed. Too far and your print won't stick, leading to the aforementioned spaghetti. So, mastering bed leveling, whether it's manual with those little spring-loaded knobs of doom, or with a fancy auto bed leveling sensor, is a rite of passage for every 3D printer enthusiast. It's tedious, but oh so satisfying when you nail it. Next up, let's talk about the extruder. This is the muscle of the filament feeding system, the tireless worker that grips the filament and precisely pushes it, or pulls it, depending on the setup, towards the hot end where it gets melted. Think of it as the very determined usher, meticulously guiding the filament to the main event, ensuring it arrives just in time and in just the right amount. Without a well-functioning extruder, your hot end would be starved of material, and your prints would be weak, under-extruded, or just plain non-existent. It's a small part, but it carries a lot of responsibility for print quality. Extruders generally come in two main flavors: direct drive and Bowden. In a direct drive system, the extruder motor is mounted right on top of the hot end, pushing the filament directly into it. This gives you really precise control over retraction, which is great for stringy filaments or flexible materials. The downside? It adds weight to the print head, which can limit your print speed if you don't want a wobbly mess. Then there's the Bowden setup, where the extruder motor is mounted on the printer's frame, and it pushes the filament through a long PTFE tube, the Bowden tube, to the hot end. This makes the print head lighter, allowing for faster movements. But it can sometimes struggle with flexible filaments and might need more fine-tuning for retraction settings. It's like choosing between having your backpack right on you or pulling a little cart behind you. Both get your stuff there, but in different ways. No matter the type, keeping your extruder happy is key. This often involves calibration, specifically something called E-steps calibration. This process tells the printer exactly how much filament is being pushed for every step the motor makes. If this isn't calibrated right, it's like trying to bake a cake, but your measuring cups are all wrong. You'll get, but probably not what you hoped for. You might also encounter issues like filament grinding, where the extruder gear chews up the filament instead of pushing it or slipping, where it can't get a good grip. These are usually signs that something needs adjusting, maybe tension, maybe temperature, or maybe you just need to clear a pesky clog downstream. The extruder is a hard-working part, so give it some love. Now we arrive at the part where the real transformation happens, the hot end. This is the fiery heart of the operation, the tiny volcano that melts the solid filament and extrudes it through an even tinier nozzle to build your creations, layer by molten layer. It's where plastic goes to become potential. The hot end's job is simple in concept, get hot enough to melt plastic, but it has to do it precisely and consistently. Too hot, and your filament becomes a droopy, stringy mess, or even burns. Too cold, and the filament won't melt properly, leading to clogs or poor layer adhesion. It's a delicate temperature dance that the printer manages for you, thankfully. A typical hot end is actually an assembly of a few key components working in concert. You've got the heater cartridge, which is basically a tiny, powerful electric heater. Then there's the thermistor, a temperature sensor that tells the printer's brain how hot things are, allowing it to regulate the temperature. These are usually embedded in a heater block, a small metal block, often aluminum or copper, that distributes the heat evenly and holds the nozzle. Above that, you'll usually find a heat sink and a fan, which are super important for keeping the cold end of the hot end cool. This prevents the heat from traveling too far up the filament path and causing it to soften and jam before it even reaches the melt zone, a dreaded phenomenon known as heat creep. It's a miniature marvel of thermal engineering. And let's not forget the nozzle, such a tiny hole, but it dictates so much about your print, the level of detail, the print speed, and even the strength of the part. Nozzles come in different sizes, typically from 0.2 millimeters for superfine details up to 1 millimeter or more for faster, chunkier prints. They also come in different materials, like brass, the most common, stainless steel for food-safe or abrasive filaments, or even hardened steel or ruby-tipped ones for really tough abrasive stuff like carbon fiber-filled filament. Oh, and clogs. We all get clogs. It's a rite of passage in 3D printing. Learning how to identify and clear a clogged nozzle is an essential skill, like knowing how to change a flat tire, but for robots. Let's talk about the parts that make everything move, the stepper motors. These are the unsung heroes, the precision dancers that move the print head in the X and Y axes, and the print bed, usually in the Z axis and sometimes Y as well, exactly where they need to go, with incredible accuracy. Without these trusty motors, you'd just have a hot extruder making a very artistic but ultimately useless plastic puddle in one spot. They are responsible for translating the digital coordinates from your 3D model into physical motion, building your object one tiny step at a time. It's quite amazing when you stop to think about the thousands, even millions, of precise movements they make for a single print. Stepper motors are fascinating because they don't just spin continuously like a regular DC motor. Instead, they move in discrete steps, or tiny rotational increments. This is what allows for such precise positioning. The printer's control board sends a series of electrical pulses to the motors, and for each pulse, the motor shaft rotates by a specific fixed angle. There's no complex feedback system needed to know where they are, in most consumer printers anyway. The printer just trusts that if it told the motor to take 200 steps, it took 200 steps. This is why they are perfect for applications like 3D printers, CNC machines, and other robots where accuracy is paramount. It's kind of mesmerizing if you watch them closely, like a very, very patient robot performing a complex ballet. Of course, even these precise workhorses can have their off days. If the motors are asked to move too fast, or if there's too much resistance, like a binding axis or a belt that's too tight or too loose, they can skip steps. This means the motor tries to move but doesn't quite make it, leading to layer shifting in your print, that dreaded look where your print suddenly jogs sideways. Overheating can also be an issue for stepper motors, though it's less common. Ensuring your printer's mechanics are smooth, belts are properly tensioned, and the motor drivers on the control board are set correctly can keep these guys happy and stepping accurately. They are the quiet backbone of your printer's precision. Finally, we arrive at the brain of the entire operation, the control board, also known as the main board or motherboard. This is mission control, the central nervous system, the big cheese that coordinates all the other components we've talked about. It takes your sliced 3D model, the G-code file, interprets the instructions, and then tells the stepper motors where to move, the hot end what temperature to maintain, the fans when to spin, and the extruder how much filament to push. It's a complex juggling act, managing temperatures, motion, and timing, all to bring your digital design into the physical world. If the hot end is the heart, the control board is definitely the brain. The control board is essentially a small computer, packed with a microcontroller, like an Arduino on steroids for many printers, or more powerful 32-bit processors these days. Motor drivers, chips that send the precise electrical signals to the stepper motors, connectors for all the sensors and heaters, and inputs for things like SD cards or USB connections. It runs special software called firmware. Think of it as the printer's operating system. This firmware, like Marlin Clipper or RepRap firmware, is what reads the G-code instructions line by line. G-code is basically the sheet music for your print. A long list of commands like G1X10Y20, E5F3000, which might mean move to X coordinate 10, Y coordinate 20, extrude 5 millimeters of filament at a feed rate of 3,000 millimeters per minute. The board processes these commands at lightning speed. Without a functioning control board, your 3D printer is just a collection of interesting parts, a very expensive and slightly sad paperweight. It's the central hub for everything. It's where you typically load your files, often via an SD card slot directly on the board or a USB port for connecting to a computer. Some fancier boards even have Wi-Fi or Ethernet for network printing. Understanding that this board is orchestrating everything can be really helpful when troubleshooting. If multiple things are going wrong or the printer is acting erratically, sometimes the issue can be traced back to the control board or its firmware. It's the unsung hero that makes the whole symphony of 3D printing possible. So there you have it, a whirlwind tour of the essential anatomy of your 3D printer. From the foundational print bed to the mighty extruder, the fiery hot end, the precise stepper motors, and the brilliant control board, each part plays a critical role in turning a digital dream into a tangible reality. Hopefully, peeling back the cover and peering into the guts of your machine has made it all a little less mysterious and a lot more fascinating. It's like learning how your car works. You might not become a master mechanic overnight, but you'll definitely appreciate the engineering more and feel more confident when something inevitably needs a little TLC. Understanding these components is your superpower. It means you can start to diagnose why that print failed, figure out what that weird noise is, or even plan your first upgrade with a bit more know-how. Remember, every 3D printing expert out there started exactly where you are, learning one part, one concept, one frustratingly failed print at a time. The journey is all about experimentation, learning from those happy little accidents, and the not-so-happy ones, and continuously building your knowledge. So don't be afraid to tinker, to ask questions, and to try new things. That's where the real fun and the real learning happens. Thanks for watching. If you found this video helpful and maybe even a little bit entertaining, don't forget to like and subscribe for more 3D printing tips, tutorials, and probably a few more of my questionable inventions. Your support really helps the channel grow, and it lets me know I'm on the right track with making content that you find useful. Go forth and print something amazing. or at least something that makes you laugh. See you next time.